Good morning, grade 11s, or good afternoon. We're going to continue with the exponential function today. It is something we did last year, and you also had revision a few days ago. So we're just going to, I'm going to start off, before we sketch it, I'm just going to give you a bit of background and the effect that the different variables have. So in grade 10, you dealt with this as your standard equation. And now in grade 11, you're going to deal with this one on the right here. And the only difference you'll notice is that we've now got a plus p, which is an indication of a shift to the right or to the left. But we'll talk about that a bit later. And I'm going to start off by having a look at how B affects the graph, how A affects the graph, how Q affects the graph, and how P affects the graph. So we're going to have a look at each of those in turn. The first one we're going to look at is the effect of B. Now B is this over here. Okay, it's the base of the variable x. So now let's have a look. The first thing we need to look at is if B is greater than 1. So if it's 2 or 3 or 4, then it's an increasing exponential curve. It just goes up, and because it's exponential, it grows very, very quickly because the x is an exponent. So as x gets bigger, so your y gets bigger very, very quickly. The other one is now if we have B to be a fraction. Remember, B can only be between 0 and 1. It can't be negative ever. So if we take, for example, B as a half, then as x gets bigger, so the y gets smaller. We call that a decreasing graph. It goes down as x gets bigger and bigger and bigger along the x-axis, so y gets smaller and smaller and smaller. Now, the interesting thing about these two graphs, these particular ones that I've drawn here, is that these two graphs are reflections around the y-axis. And I think you can clearly see that. They're like a mirror image. The purple one is a mirror image of the blue one around the y-axis. And remember, if we remember from reflections from long ago in grade 9, is that if I have that's the blue graph. Let's see. If I've got the blue graph here, y equals 2 to the x. If I reflect it around the y-axis, then the x changes to a negative, or from a negative to a positive, or positive to a negative. And 2 to the minus x now can be written, from your knowledge of exponents, as a half to the power x. Remember, we take the 2 from the top to the bottom, and then the exponent changes from a negative to a positive. So these two are reflections around the y-axis. The other important thing to notice with your exponential curve is that we also have an asymptote. And your asymptote in these cases here is going to be your x-axis. Because remember, what happens is that this graph, if it continues, gets very, 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 very close to the x-axis, but it never ever cuts it because it's undefined when y is 0. In other words, it's an asymptote the x-axis is an asymptote because it never ever cuts the x-axis. It's never defined when y is 0. Okay, so that's your basic exponential curves from last year. Now, let's have a look a little bit more on the effect of B with the shape. We're still looking at the effect of B. Basically, as B gets bigger, the graph gets steeper. That's just the easiest way to remember it, is the greater the value of B, the steeper the graph gets. And once again, all of these things are important to know, but they're not essential because we can just use our calculator to sketch the graph. But it's interesting to see the effects of the different variables, and when we work in backwards from the sketch to find the equation, it's important to know these different facts and how they affect the shape of the graph. Okay, now let's look at the effect of A. Let's go back to our original equation. Here. So A is the number in front of the B. That's where your A is. So if we go back now to the effect of A, let's have a look. I've drawn 3 graphs here. The first one is y equals 2 to the x, the one we've just drawn earlier. It's this black one here, y equals 2 to the x. Cuts the y-axis at 1, where x is 0. So basically here, if you made x 0, you would get 2 to the 0 is 1. So that's why it cuts there at 1, and it climbs very quickly. Now, if I put a 3 in front and a was 3, what would happen is it would climb even quicker. That's the orange curve here. It would climb even quicker, but what it's doing is it's stretching out. It's stretching the graph up and out and away from the x-axis. And then the gray graph here, if a becomes a half or becomes smaller, the y-intercept is now a half, and it doesn't stretch it out so much. It kind of is closer to the x. It doesn't climb so quickly. And then if we make a negative, so we make a negative down here, we have y equals to a being minus 1 times 2 to the x. Now that minus flips the graph around the x-axis. So instead of increasing, it now decreases. It's a decreasing function. You can see that over here. So instead of cutting the the y-axis 1, it now cuts it at minus 1. And it's a reflection around the x-axis. I think you can see it. It's like a mirror image around the x-axis. And how does that tie up with the theory? It ties up because, remember, a reflection around the x-axis, the y changes. So the y changes on this side, but then you actually bring it to the other side, and that's why you get a minus there. Okay, and then similarly with the others as well, you now have minus 3. So instead of going up and increasing, it becomes a decreasing graph. And similarly with the minus a half as well. So that minus half means it's a reflection around the x-axis, and instead of increasing, it now decreases. Becomes a decreasing function. Okay, so that's the effect of A. So once again, the greater the value of A, the further the graph is stretched away from the asymptote, or in the example I use the x-axis. It's kind of stretching, it's growing quicker, if I can put it that way. Okay, then we have the effect of Q, which is the plus minus Q at the end. Now that's a nice easy one, because remember always the plus or the minus Q. If it's plus Q, then it shifts the graph up, and if it's minus Q, it shifts the whole graph down. And in the exponential function, the Q always indicates the asymptote. The asymptote will then change. The graph is not defined at the asymptote, so it changes. So now if we look at this in terms of a sketch quickly, if I have my exponential graph, y equals 2 to the power x plus 1, I'm just focusing at the moment on the Q. The plus 1 indicates that my asymptote is now going to be at plus 1. So y is equal to 1. That's the asymptote. And if we do quickly sketch this, that value of b is at 2. So it's going to be an increasing graph. And it's going to cut at 2. Once again, let's focus on the Q here. It's minus 3. So that means my asymptote is, the whole graph is moving down 3 units. My asymptote now is a graph y equals minus 3. And because it's still a positive b, positive 2, it climbs up. And we would then need to go and work out what the y-intercept was and the x-intercept. Okay. Get rid of this here. Okay, so that's the effect of Q. And lastly, we have the effect of P. Now, that's the only one that's new, really, is that little plus P, x plus P or x minus P. And what we need to know here is that if it moves to the right or to the left. Why? Because if you look, it's x plus or minus P. So because it's x, it's the x-axis, which is the horizontal axis, so it'll be to the right or to the left. If it's plus 2, as in the first example here, it moves 2 units to the left. It's always the opposite direction. And in the second scenario here, it's minus 2, so it moves to the right 2 units. But once again, when you actually sketch the graph, it doesn't really even matter, it doesn't really affect it. It's just that you need to know that if we then change this graph with a move to the right or move to the left, that is what gets affected. The P gets affected. Okay, now let's move on to actually sketching some of them. So we look at the first example. F of x equals 2 to the x plus 2 minus 2. We're going to sketch this graph. So keep it in mind now that we have the standard equation like this. We're going to first look at B. So B in this case is 2, which means my graph is going to be an increasing graph. The second thing we're going to look at is the value of A, and it's 1. So there's no reflection around the x-axis moving down. The third thing we look at is the value of Q, which is your asymptote. That means it shifts down 2 units. And so my equation of the asymptote is going to be y equals 2. The value of P, that's my P there, plus 2, means it's going to shift to the left 2 units. Okay, so we've kind of got an idea now of what this is going to look like. If I just draw a quick rough sketch. Let's go, it moves down to minus 2. And it's going to do this shape. Now we need to just end up by finding out what the x and the y intercepts are. Okay. So the y-intercept, what do? We make x naught as always, and my y-intercept is 2. X-intercept, make y naught. We take the minus 2 across to the other side, so it's 2. And then don't forget our exponent laws. We've got the base is the same. They're 2 and 2, so we drop them, and we end up with x plus 2 equal 1. So my x is minus 1. So my x-intercept is minus 1, 0, and my y-intercept is 0, 2. Now, let's see how this all comes together. I've already drawn it. So let's see, my y was minus 2. So that's what we start there. Then we found our x-intercept was minus 1. Don't forget we need to write it as a point. Minus 1, 0. My y-intercept was 2, so it's the point 0, 2. Got my asymptote. Here it is, y equals minus 2. We must always write that. It's useful to write it on because they always end up asking it. And then don't forget, we also need to label this graph. What was it? It was y equals, where are we? 2 to the x plus 2. 2 to the x plus 2 minus 2. So we've labeled our graph. If you want, you can put little arrows on that to make it look nice, neat as possible. And then we needed to find the domain and the range. Remember, the domain is always all the possible x values. Now, if we look at our exponential function here, essentially, this is going to keep climbing, not so. And this is going to keep going, decreasing, decreasing, but never cutting the line y equals minus 2. So essentially, there's no x values that it can't be. So x can be any value. So then our domain is x, an element of real numbers. Then don't forget, we want to find the range, which is our y values. Now, if we look at the y values, okay, we're focusing on the y-axis. Now, I always work kind of in the negative, in the reverse. So I always say, is there any y values that this graph doesn't have? And absolutely, there's no y values down here. So the only y values that I have are these going up. So in other words, it's from minus 2 going up. So if it's from y, it's anything bigger than -2, can't be equal to -2 because that -2 is an asymptote. Some of you might prefer to write it differently. So it's from -2, that's the lower limit, up to positive infinity with round brackets because it excludes -2. Okay, so that's a domain and range. Let's do another example. Okay, so this is my question. Y equals a third, x minus 2 plus 3. And I'm going to start moving a little bit quicker. So the value of the b here is a third. So then my shape is not, it's going to be decreasing. So that's my shape. The value of a is 1, so it doesn't flip around the x-axis. The value of q is 3, so that means my asymptote is going to be y equals 3. So if I quickly sketch it over here, it's going to be up there. That's going to be my asymptote. The value of p here is -2, so the whole graph is going to shift to the right 2 units. But once again, we don't actually use that in the sketching. My y-intercept, I make x0, so it's going to be y equals a third, 0 minus 2 plus 3. And that's when I take out my Casio, so it's going to be a third to the power -2. And I get 12. Wow, okay. So that means as a point, oopsie, what's happening there? So as a point, it's going to be 0, 12. Then we go now find our x-intercept, which means we make the y0, and that's going to be a third to the x minus 2 plus 3. Take our 3 across. And this is a standard way that we always do it. We always take the q across. So then we get -3. Now straight away I can see that's not going to work. There's going to be no x-intercept. Why? Because I can't have a negative equal to a positive. It doesn't make any sense. So now we're going to go back and draw it. Let's remind ourselves. My asymptote was y equals 3, cuts at 3. My y-intercept was 0 and 12, which is up here. And what did my graph do? B was a third, so it was sloping down like this. Okay, we need to extend this a little bit. Oopsie. So we're going to do this. There's my graph. Okay. Let's probably get rid of a bit of, oh, then the whole line's going to go. Okay, that wasn't a good idea. Okay, so I've kind of squashed it up a little bit at the top. Probably needed to maybe move the whole thing down a bit. And then let's finish off by doing the domain and range. Now remember, this graph is going to continue this way and continue up. So once again, my domain is going to be everything. X is an element of real numbers. And the range is not here. It just goes from 3 upwards. So once again, my y is going to be greater than 3. Not equal to 3, but greater than 3. If you want to write it in the other notation, it's going to be from 3 upwards, from 3 to infinity, both with round brackets. Okay. Last one. I've done 3 because I want to make sure that you're confident with this. Okay, so we've got our standard equation. So my b is a half, so the curve goes down like that. The a here is -3, so that's the first time that we have a flip. So this is my original curve, but because the a is negative, it now flips around the x-axis and goes down to the bottom. My q makes my asymptote of y is 3. In this case, there's p is 0, so there's no shift to the right or the left. My y-intercept make x 0, and we get 0, 0. X-intercept, we make y 0. Take the 3 across, we get -3. -3 divided by -3 is 1. And then remember our little trick here. 1 can be written as 2 to the 0. And in this here, our knowledge of exponents can't be forgotten, is a half can be written as 2 to the minus 1. So a half to the x is the same as the 2 to the minus x. And we end up with an x-intercept of 0. So now we go and sketch it. Okay. So my asymptote was up here, plus 3. Let's write y equals 3. The equation cuts at 3. My y-intercept was 0, 0, as was my x-intercept. And what was the shape again? It flipped around, so it's doing this. Boom, 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 boom. Let's make sure I've got everything. I've got my x-intercept, my y-intercept, I've got my asymptote, and then I need to finish off by labeling the graph. Y equals minus 3. It was a half to the x plus 3. And I've labeled my graph. Okay, let's end off with the domain. Once again, the domain of every exponential is x an element of real numbers. The range, in this case again, I have no y values up there. They all go down. So they're smaller than 3. So my range is going to be y smaller than 3. Okay, pointers. Once again, you can always use the calculator. And then remember, you've got that table key. And you can plot a few points, all your x's and your y's. And just to see that you've actually got it going in the right direction. But we can't go wrong with the following. What we do is you identify your b to see if it's increasing or decreasing. See if your a changes the way it reflects. Get your asymptote, y-intercept, x-intercept. So those are the 5 points. Check your b. Does the a change anything? What is your asymptote? What is your y-intercept? And what is your x-intercept? And then voila, off you go and sketch your graph. Now to practice a few grade 11s, it practices on page 80, exercise 5, A, B, and C. The memo is already up, so once you've done A, B, C, go and check the memo. You've got 2 days to do this, Friday and Monday. So good luck.